Hello everyone, welcome to second video of our biostatistics. In this video, I'm going to talk about relative risk and odds ratio. They are very important topics as far as we talk about exam, and even if we talk about our clinical studies. We can formulate our research papers and we may require these things. So it is very important to understand these two topics very well. So I'm going to cover these topics in a very short and sweet manner so that you are able to work for your exam questions and you have a basic understanding of what this equation is. So because the subject is scary, so I've made the screen extremely colorful. So welcome to this colorful session of relative risk and odds ratio. So here we go. We'll start with quantifying associations. So basically, in our last videos, we have talked about data, how and what type of data is there. So now once we accumulate all our data, we have to quantify, we have to see how these data work. So now when we talk about associations, that is a particular thing is associated with certain risk, this is a risk factor for something. So this type of associations, when we talk of, how do we quantify how much risk, how much is the association responsible? So we have two factors here. One way we can quantify association is that we can estimate risk, and the other way is the odds calculations. So we have two types of calculations, right? We will just not talk of why we have two types of quantifications, why just we cannot go with risk estimation. So we are just now going to highlight on that. So risk estimation, it deals with proportions. Risk can either increase or decrease. So basically, like an example is a person, a group of people, like obese people. Okay, so what is the risk that they can develop stroke in a later part of life? So I say that I take a sample population and the risk factor here is obesity, and we are going to see the disease outcome. So we are going to follow these obese people over a certain period of time, and then we will see how many have developed stroke and how many have not developed stroke. Other group will be which are non-obese people, and in that case, how many developed stroke and how many did not develop stroke. So we have some type of exposure. Exposure is your obesity here, the BMI. The high BMI is the exposure here, and outcome is development of stroke. Okay, so they are categorical variables. Either person can be obese or non-obese, or person can develop smoke and stroke or does not develop a stroke. So now we have to see what is the risk. Okay, so what is the risk? We are going to follow these person over a period of time. So what we are doing a cohort study or a prospective study. What is prospective study? We take a group of people and we follow them over a period of time to see how many of them develop a disease, right? So we are going starting in present and going in future. So this is prospective or cohort study. So this is risk estimation. So certain factors, they can have increased risk. Certain factors can have protective risk. Example of protective risk factors are like we say that people who exercise 5 days in a week, people who do not exercise. So exposure here is exercise. Okay. So now how many developed cardiac disease? So or how many developed hypertension in the future and how many did not develop hypertension. So in this case, we might find a risk reduction. We may find that exercise is a protective factor. We'll just now see how we interpret the risk estimation. So this is certainly a risk, like a person is exposed to something and then he can have some particular outcome or not. So what is the proportion, how much, what times person can have that risk, or what times that factor can be risk reduction factor. So that deals with risk estimation. Now, why we need odds calculations and what is this odds calculation? So, what is odds? Odds means a probability of an event happening. Okay. So, probability of certain event is happening. So now what happens is, like certain events, like if we look at lung cancer, okay, so that may develop in a certain people. Like we need, if we want to see and follow 20 people of lung cancer, we need to see whether smoking leads to lung cancer or not. So we have to follow smokers and non-smokers. But lung cancer, that is not going to happen to everyone. It is something which is going to happen to only a small population. So your disease is a small population. So for that, you need to take a big sample. Like if you want to look at maybe 50 or 100 patients of lung cancer, you might need to have a 10,000 population. So that will be a very difficult thing. So for these types of things, what we do is we do a case control study. What is case control study? We take up cases. That is, we take patients of lung cancer. We take 100 patients or 200 patients of lung cancer, whatever sample size we decide. And then we go retrospectively and we try to search how many of them were smokers and how many of them were non-smokers. Then we take another control group of 200 people of who don't have lung cancer, and we go back and see how many of them were smokers and how many of them were not smokers. So this way we calculate what is the odds of lung cancer happening in patients who were smokers. Okay. In this case, we are going back. We are going retrospectively. We are starting from the disease and going back to exposure. So here we cannot calculate risk because we are not going from exposure to outcome. So how we can calculate risk in this? The pattern is odds calculations. Okay. So odds calculation deals with probabilities. What is the probability of event happening in a population? So risk estimation is more correct, while odds is sometime overestimated figure. So therefore, but in case control studies, we cannot do risk estimation. So therefore, we need odds calculations. I hope I answered your question. Why we are carrying these two in our hands? Why we are not dealing with one? Okay. So therefore, we have odds calculation. So risk estimation is largely for the prospective data. Prospective data, the new persons who are carrying that disease. So incidence. It is dealing with incidence over a period of time. How many people have developed a disease? While odds is largely for the case control studies, for the retrospective studies. Now let's see how we calculate these. So risk estimation, how much more likely a person will develop an event. So risk is the chance of event being occurring if a person has certain exposure or if a person does not have an exposure. So we have this type of a chart: exposed, unexposed, disease is there, no disease is there. So we have in exposed group, certain people may develop disease and certain people may not develop disease. While in unexposed, some people can develop disease and some may not develop disease. So now we'll look at this data. So how we define? We have three things to define. One is how much is the risk. Another is what is absolute risk. And the third thing which we are going to talk is relative risk. How do these three things differ? So risk calculation. How do you calculate risk? Risk in given group. Either we take a control group or we take a observation group. That is, either it is a control group if it is non-exposed, it is an observation group if it is exposed. Okay. So what is the number of event occurring upon total population in group? So what is the event occurring upon total population in group. Let's go back to this chart again. So in this number of event, if I tell you we have to calculate risk for the exposed group. So how we will calculate? The number of people who developed event, that is A, divided by total number of people who were exposed. So A upon A plus B. If I say we have to calculate risk for the unexposed population, then C are the people who develop disease. So C divided by total population in this group. C upon C plus D. So this is how we are going to calculate the risk. I would suggest that rather than remembering A, B, C, D, it's good to remember that whatever group we are dealing with, we have to keep in numerator number of events occurring, number of people who develop disease, or number of events for whatever thing we are looking for, depending on total population in that particular group. Because sometimes the thing is different. Here on this part, instead of exposure, you have been given disease, and the other part, it is the exposure. So you may get confused putting up A, B, C, D. So it is good to remember, if you see it, remember it like this: number of events occurring upon total population in group. Absolute risk. So absolute risk is difference in risk between two groups. So risk in observed group minus risk in control group. So risk in observed group and risk in control group. So now we know how to calculate risk in observed group. We have to keep in numerator number of people who developed disease or who were positive for the event divided by total population of observed group. While risk in control group is the number of people who develop disease in control group upon total number of people in the control group. So like this, we can calculate absolute risk. Now there is another term, relative risk. It is a ratio. We are looking at how much times the risk is there. Okay. So like if in numerator it comes, final answer comes out to be 3, like relative risk is 3. That means the 3 times risk is there in an observed group. So here again, relative risk is risk in observed group divided by risk in control group. So we already know how to calculate the risk. The same formula, the number of events occurring upon total population of observed group. In control group, we will add number of events occurring upon total population in control group. Here is a good example. So this is, again, we are coming to same chart: disease, no disease, exposed and unexposed. So relative risk will be disease risk in exposed. So therefore, disease upon total A plus B. Then divided by disease risk is non-exposed. So this is C divided by C plus D. So this is relative risk. This is how we calculate relative risk. Now, how do we interpret relative risk? If this ratio comes out to be 1, that means the numerator and denominator are equal. So risk is equal. Risk is equal in observed and control group. So there will be equal. So means no difference between groups. If we say that relative risk is more than 1, means in observed group, the risk is more as compared to control group. So there is greater risk. If relative risk is less than 1, this means the control group have a higher risk. The denominator is bigger as compared to numerator. So the risk in control group is higher. So therefore, observed group has less risk. So whatever we are looking at, factor is actually protecting. It is decreasing the risk. So it is a protective factor. Let's solve this question. So now in this case, this is 366 is the patients who were exposed and they got disease. But 32 is the figure for those who were exposed but they did not develop disease. Unexposed population, 64 developed disease, while 319 did not develop disease. So now if you have to calculate relative risk, then number of people in the exposed group developing disease, we keep this in a numerator, divided by total number of people in exposed group. So 366 plus 32. Now we are dividing this by 64, which is the number of people who develop disease in unexposed group divided by total population in unexposed group. So 0.92, if you solve this, it comes out to be 0.92. If you solve this, this comes out to be 0.17. If you divide this, then it is 5.41. So the relative risk is 5.41. So that means the risk factor which we are testing that increases the risk of disease 5.41 times. Another example of relative risk. Here we are looking at a disease. Now you see what I was talking of. The things can change. You can have exposure here and disease here. Okay. So that is why I was saying don't remember as A, B, C, D. Remember it as exposure and outcome. Okay. So this is exposure. Exposure is people are smokers and people are non-smokers. And this is the disease outcome, bronchogenic carcinoma and no bronchogenic carcinoma. So incidence of new cases in smokers. So basically now we have to calculate relative risk. So what is happening? The disease is developing in smokers is 10 cases. You see it is 10. So 10 upon total number of smokers, total number of population who had exposure. So the numerator is 10 by 100. Okay. So this is 10 by 100 risk in the exposed group. So it comes out to be 10%. Okay. They are calculating in percent. So 10 by 100 into 100. So that will be 10%. Or else you can take it as 0.1. Right. So this is how it is going to be. Now in the second group, here it is 1. So it is 1 upon 100. Okay, so 1 upon 100, it is like 0.01 or 1%. So now if you divide 0.1 with 0.01 or you divide 10 by 1, the answer comes to be 10. So that is relative risk. So what we conclude that smoking is a risk factor for this outcome, which is bronchogenic carcinoma, and it increases the risk 10 times because relative risk is more than 1. So this is a causative factor, or this is a factor which is increasing a risk. So, and that to 10 times increase. Now let's talk about odds ratio. So now in odds ratio, what we are doing, we are comparing the odds in two groups. Okay, so that is a ratio. Like in that case, we have a ratio of risk in two groups. Here we are having odds in two groups. So this is alternative of risk and is used in non-prospective studies. So as I already explained, we are going to use this in case-controlled studies. Odds is ratio of the probability that an event will happen to the probability that it will not happen. So odds in given group is number of subjects with event upon number of subjects without event. Okay. So now compare this with the relative risk. In relative risk, numerator was same. We were taking number of people who developed disease or number of people with the event. But in the denominator, we were taking the total population of that exposure. But here we are taking number of subjects without event. Okay. Because we do not have total population here. We are doing this in case control study, and in case control study, we are not taking a sample of population. We are taking either two groups One is disease group and one is control group. So we cannot have total population here. So when we don't have total population, we cannot calculate relative risk. That is why we require this formula of odds here in case control studies or retrospective studies. So number of subjects with event divided by number of subjects without event. Very important to note here this point. We are not taking a total population of exposed group as we were taking in relative risk. Okay. So mind you again, this is number of subjects with event divided by number of subjects without event. Now let's take this chart. Again, there is a exposure and these are unexposed. Some people develop disease and some people did not develop disease. So now we are taking case control studies. So we are taking two populations. One is case population, one is control population. For example, I'll talk of smoking and lung cancers. So we took 100 cases of lung cancers and we took 100 cases of no disease, normal people. And then we looked on to how many were smokers and how many were non-smokers. So odds of a case, odds of a disease in a case who was exposed. What is the chance? What is the probability that the disease will occur in exposed population? So we are going to divide A by B, right? So in this, A divided by B. What is the chance of the disease in exposed population? So A by B. What is the chance of disease? What is the odds of disease in unexposed population? So disease development is C. In unexposed populations, C upon D. How many developed disease? How many did not develop disease? So A developed disease, B does not develop disease. So A by B. C developed disease and D did not develop disease. So C by D. Okay. We do not have total population sample here. We cannot add up A and B because we have taken two different groups. It is not same population sample. In relative risk, we took one population sample here. And then we decided these two. But here in case control, we are starting with two population samples and they are different. So we cannot combine these two. So therefore, A by B and C by D. Let's take this example. So now the same calculation we had there. This is a group of 100 people who were okay, sorry. So we are going to take here case control studies. So we took 11 people in the bronchogenic carcinoma group, out of which 10 were smokers and 1 were non-smokers. And in this, we took around 189 people in non-bronchogenic carcinoma, that is normal people who did not have lung cancer, and asked them, 90 were smokers and 99 were non-smokers. So this is how the sample was. Now, if we have to calculate the odds ratio in smokers, then it is going to be 10 by 1. So, sorry, 10 by 90, because we are going to take exposed who developed disease and who did not develop disease. So, 10 developed disease, but 90 did not develop disease. So, it is 10 by 90. In the other group, odds of cancer cases in non-smokers, it is 1 developed disease divided by 90. So, this is 0.0101. So if we divide this, it comes out to be 11. Sorry. So it comes out to be 11. So this is how we calculate the odds ratio. It is A by B and C divided by D. A by B ratio is here. Then C divided by D ratio is here. So finally, it comes to be 11. So that means smoking has approximately 11 times odds of developing bronchogenic carcinoma. So relative risk or the odds ratio is 1, no association, greater than 1. Exposure leads to increased chances of outcome. If it is less than 1, exposure is protective against the outcome. If event is rare in control group, if event is occurring is very, very rare. So rare means it is happening in 10,000 cases. So in that case, the OR is equal to relative risk. Now, how do we know that what figure we have got is significant or not? So there are two ways of looking at this. One is p-value. P-value is probability of obtaining false positive result. So if your p-value is less than 0.05, then it is significant. What does this mean? 0.05. Okay, if you just remove this point and take it as 5 by 100 because it is 0.5. So if we remove the decimal, we will have 5 by 100. So that means we divide 5 by 100, it becomes 1 by 20. So 1 in 20 chance that this could have happened by chance, and this is not a result. This is not a correct result, and this happened just by chance. That means the result is false positive. So out of 20, only one chance is there that the result may be false positive. So if that is there, we say that this result is significant. Second thing is you can make a confidence intervals. So if the confidence intervals crosses 1, like it starts from 1.5 and goes to 0.9, 0.8, so it crosses 1, then there is a difference in values of two groups becomes insignificant. Let's practice with some examples. So calculate the odds of asymmetrical IUGR and symmetrical IUGR for APGAR less than 7 or greater than 7. So now, here is the exposure. Okay. So APGAR, this is the outcome. So basically IUGR exposure is there. Either baby was IUGR, asymmetrical or symmetrical, and then finally on birth the APGAR was less than 7 or more than 7. So this is the exposure and this is outcome. Now we have to calculate the odds ratio. So what would be the odds of asymmetrical IUGR and symmetrical IUGR for APGAR less than 7? So we are only going to look at this APGAR less than 7 point. So here, the ratio will be 1 divided by 1. 1 divided by 1. Babies who developed asymmetrical and those who developed symmetrical. So 1 divided by 1. What is the odds of asymmetrical IUGR in group APGAR less than 7 is 1 divided by 1. So your answer will be 1. In this case, calculate relative risk reduction for a medication tested for its pain relief effect. So we have to calculate relative risk reduction here. This is the chart we have. So this is the exposure. Patient was exposed to new drug or to the placebo, and these are the pain relief and no pain relief. So with new drug, 50 out of 100, we had 100 population. So out of 100 patients, 50 had a pain relief, 50 did not had a pain relief. With placebo, 20 had a pain relief and there was no pain relief in 80. So what is the exposure? Exposure is the drug. So this is exposed group and this is non-exposed group. So now for risk calculation, the event occurring divided by number of people in that group, right? So event occurring here is pain relief. So 50 divided by total number of people in that group, 50 by 100, right? It is divided by, because this is relative risk is a ratio, event occurring in the other group. So that is pain relief is the event. So it is 20 divided by total population 100. Okay. So 50 by 100 divided by 20 by 100. So here you can see 50 divided by 100 will be 1/2 or 0.5. So 0.5 divided by 0.2. So finally it comes out to be 2.5. So your correct answer is 2.5. So the medication is 2.5 times reducing the pain in these patients. So that was about calculation of odds ratio, relative risk ratios, and what is their importance. I hope this was clear to you. Your feedback, your queries are always welcome. MRCOG courses is always there for your help. It always seems impossible until it is done. And it is very true for MRCOG, and particularly if I talk about biostatistics. So this is Dr. Bhavna Khera signing out, and very, very warm welcome for all the courses, all the sessions for the MRCOG, whatever you are looking for. We are always there for your help. Anything regarding MRCOG, we are here. Thank you so much for your patient listening.